look at is summation notation. To get the capital sigma, we're going to use the command \sum. If I compile that, it's going to be pretty short. So usually that is written much larger than the text beside it. So we can make it larger using display style, display style, curly bracket. We go to the end and put the closing curly bracket. If I compile that, now you can see the size is much larger. We want our sum to go from n equals 1 to infinity. I'm going to use \limits. So I'm going to use then an underscore, and on the bottom I want n equals 1. That's not a single character, so this time I have to use the curly brackets. N equals 1, close the curly brackets, use the caret, and now we're going to type our upper bound. So this time I want to go to infinity. So in the curly brackets I'm going to type \infty and close the brackets. Let's compile and see what we have there. Okay, so we have the sum from n equals 1 to infinity. And let's keep going with that. I need to be in front of the last curly bracket because that closes the display style. And we want to take, let's see, the sum of, let's do geometric series, a times r to the power n. And that is equal to, let's go ahead and compile so we can see where we are. I'm going to go ahead and expand that sum. So that is equal to a plus a times r plus a times r squared plus, now I want ... plus my nth term, a times r to the power n. Let's compile and see what we have. I have the ... but the ... should be centered vertically so that it's kind of aligned with the horizontal crossbar of the plus sign. And instead of typing ... there's a command for the 3 dots. I don't need to insert space between it, but just to keep the code nice and clean I will. And that command is /. If you just want a single dot, it's C dot. If you want the 3 dots, put an S at the end, \C dots. So when I compile this, those 3 dots should be vertically centered. For our next command, we're going to put all of this stuff together and give the definition of a Riemann sum using a definite integral. So let's open math mode, and the first thing I want to type is the definite integral of f of x from a to b. So we're going to do display style, open curly brackets. I'm going to go ahead and end them and end the math mode, and then just type in between those brackets. So we're starting with an integral, so \int underscore and then a caret b. My function will just be f of x, and then to insert a space here, \comma dx equals. Let's compile just to make sure we don't have any errors to this point. Everything looks the way we expect. Okay, with the integral from a to b, f of x dx is equal to. Now we want the limit as n approaches infinity. So \lim. I want to use \limits so that the x approaches infinity part appears underneath the lim. So underscore, curly brackets, x, and then to get the arrow, \2, to, infinity, \infty. Closing curly brackets. So that should say the limit as x goes to infinity. Let's compile. Make sure we're doing everything correctly. That looks good. Put my cursor back in front of the last curly bracket because we still want to be working inside of display style. Now I want the sum as k goes from 1 to n. So \sum \limits underscore, and I want k equals 1 on the bottom, so in curly brackets k equals 1, close that, caret. On the top, I just want n. The curly brackets are optional since it's a single character. So let's make sure we have our sum displaying correctly. Good. Now we want to take the sum of f of x sub k. So x underscore k, and I don't think I need to expand the parentheses. We can see what it looks like when we typeset it, times delta x. Now this is optional, but I'm going to go ahead and put the dot to indicate multiplication. So backslash c dot, that will be a single dot centered vertically, and I'm multiplying that by delta x. Now to get the delta symbol, for those Greek letters, it's backslash and the name of the letter. But if I just type all lowercase delta x, I'm going to get the lowercase Greek letter. So let's see what happens there. Okay, so I've got my f of x sub k. The parentheses look fine. I don't need to expand them. I've got my dot, and that is not what I wanted to see for delta x. So the delta symbol, the triangle, is actually the capital letter in the Greek alphabet. So we're just going to go back, and instead of lowercase d, it's backslash delta with an uppercase D. Let's compile that again, and now I have my delta x. We have one last thing to look at that you might run into in calculus notation, and that is vectors. So to get the vector